Hello, welcome again to the lesson of today. Last time we covered on how we can find the dimensions of the different physical quantities. We know the dimension of the physical quantities comes from the basic physical quantities. So we tried to see the dimensions of the different physical quantities. So today also want to continue. The aim of the lesson of today is to check the correctness of the equations, to check the correctness of the equations or explanations or explanations by using the dimensional analysis. So this concept is based on the principle of homogeneity, which stated that the equation will be correct if each term in the equations on either side have the same or similar dimensions. So to understand more what we are talking about, let's consider here in our question, consider the physical equations V is equal to U plus AT, where V and U are final and initial velocities of the body, A is accelerations, and T is time. Using method of dimensional analysis to check whether the equation is dimensionally correct or homogeneous. So to understand more this, we know it is, we are saying solution, we have given equation V is equal to U plus AT. So we want to check the correctness of these equations. So to check, we need to know the dimension of V, which is velocity, and also we need to know dimension of U, and also we need to know the dimensions of AT. Dimension of velocity we know. Dimension of velocity, remember this is equal to, dimension of velocity we know is equal to L t times LT exponent negative 1. So is equal to, also this is the velocity, so is equal to LT times, LT exponent negative 1 plus here. Now here we have two now. We have dimension of acceleration times dimension of time, times dimension of time. So it means dimension LT exponent negative x, 1 LT exponent negative 1 plus the dimension of acceleration is LT exponent negative 2. LT exponent negative 2 times the dimension of time is t. So here we find now we are going to have LT exponent negative 1 is equal to LT exponent negative 1 plus LT negative 2 plus 1. So finally you can get LT exponent negative 1 is equal to LT exponent negative 1 plus this is also LT times exponent negative 1. So this is very, very important. So to understand the this is, we say if we here finally get LT exponent negative 1 is equal to LT exponent negative 1 plus LT exponent negative 1. We will say this is the first term, this is the first term, and this is the second term, and also this is the third term. So to check whether dimensional analysis is correct or not, all terms should have the same dimensions. So we may say here, first term is LT negative 1 exponents, second term is LT negative 1 exponent, and third term is also LT exponent negative 1. Now, because all terms have the similar or same dimensions, we say this equation is dimensionally correct. So we say now the equation V is equal to U plus AT is dimensionally correct. Is dimensionally correct or homogeneous. or homogeneous. So this is based on the concept of the principle of dimensional homogeneity, which stated that the equation is said to be correct if all terms on the either side, left and right, have the similar or the same dimension. So this is how the lesson of today is about, to check the correctness of the of the equations, and it is governed by the principle of homogeneity. And this equation will be dimensionally correct if all terms have the same dimensions, have the same dimensions. So we say, for example, here we have our questions. For example, here, consider, we have the question here, consider the physical equation v is equal to u plus at, where v and u are final and initial velocities of a body. A is the acceleration and t is time, using dimensional analysis to check whether the equation is correct or not. So it comes from our equation. You have given v is equal to u plus at. So dimension of velocity now is equal to dimension of u. Dimension of v is equal to dimension of u is equal to plus dimension of at. So finally you have dimension of velocity is equal to lt negative 1, dimension of u is equal to lt negative 1, dimension of acceleration is equal to lt negative 2, dimension of time is equal to t. So finally you have dimension lt negative 1 is equal to lt negative 1 plus lt negative 2 plus 1. So finally you can get the first term, second term, and the third term is all the same. So finally this is the first term, this is the second term, and this is the third term. So because the same, all terms are the same, all terms are the same, all terms are the same. So this here it is negative, here it is negative. All terms are the same. So you may find the first term the same to the second term and the third term. So we say the equation here v is equal to u plus at is dimensionally correct or homogeneous. So this is all about the lesson of today. Oh, thanks.